Hello students, in this lecture you will learn about the verification of the Thevenin theorem. According to Thevenin theorem, any two-terminal network can be converted into an equivalent circuit in which there is only one voltage source and one resistance which is connected in the series of the voltage source. So this circuit is given, and from this circuit we have to find out the value of the Thevenin voltage and the Thevenin resistance, and then make a equivalent circuit of this circuit. First we will find out the value of the Thevenin voltage. Thevenin voltage is nothing, it is a open circuit voltage. When the load is removed from this circuit, the voltage appears at this point is not the Thevenin voltage. To open this path, the value of this resistance must be very high, and let's change the value of this resistance to very high, that is 9999999, and now the value of the resistance is very high, that means it behave as a open circuit, that means this path is open, that means no current flow into this circuit. A very small current, negligible flow into this part, and it can be assumed as a open circuit. Now measure this voltage, that is on the VTH at this point. Now when you click this run button, you will see this window, and now when you click on this, and this is a probe, when I click this one, then it will show the voltage appears at this point. So I click on this one, then it is showing the 6.75 volt, and you can see the value of this, it is 6.75 volt. So this is the Thevenin voltage. Pause the video and note down this Thevenin voltage. Now to measure the Thevenin resistance, we have to find out the short circuit current in this path, and then we will find out the value of the RTH is equal to VTH upon short circuit current. To find out the short circuit current, the value of this resistance reduced to 0, that means this path is short circuited, and let's the value of this load resistance is 0.0000000001. that means this resistance is very small, that means this path may be assumed as a short circuit. That means this terminal and this terminal is short circuit. Let's find out the current flow into this resistance. Again click on this one, run. Let's delete this one first. Click on edit and then delete, and then delete. Now measure the current in this resistance, and which is this value. So here click on this one. You can see the value of the 409.09. It is the short circuit current. Now note down this value, and you have the value of the VTH. With these two values you can determine the value of the Thevenin resistance. So here you have experimentally you have find out the value of the Thevenin voltage, which is 6.75 volt, and which is appeared at this point, and the short circuit current is 4.09 milliampere. Now note down these two values, that will VTH is equal to 6.75 volt and ISC is equal to 409.0909 milliampere. Then you can write this 0.409 ampere. Okay, now calculate the value of the RTH. RTH is equal to VTH divided by ISC, and it will be 6.75 divided by 0.409, then you will get 16.5 ohm. This is the experimental value of the RTH, and this is the value of the Thevenin voltage and the Thevenin resistance. So here, so let's find out the theoretical value of these two resistance. So these are the experimental values. Now find out the value of this VTH theoretically. Theoretically, the value of the VTH is equal to the voltage across this resistance is the VTH. So VTH is equal to I R2, that is V upon R1 plus R2 into R2. So here V is 9 volt and R2 is 6 volt, 6 ohm, and the R1 is 2 plus 6, that means 9 6 54 divided by 8, and when you divide this 54 divided by 8, then you will get 6.75 volt. And when you find the Thevenin resistance, then you will get R3 plus R1 R2, and the RTH is equal to R3 plus R1 dot R2 divided by R1 plus R2. Now substitute the value of this 15 plus R1 is 2 and R2 is 6, and 2 plus 6, that means 15 plus 12 divided by 8, and it is 15 plus 12 by 8 is 1.5, it is 1.5, and then you will get 16.5 ohm. Now it is verified. These are the experimental values and theoretical values, and the error. Then experimental, the VTH and the RTH. VTH is 6.75 volt and RTH 16.5 ohm. Theoretically, the value was found exactly same, 6.75 volt, and it also 6.5 ohm, and error was 0. So hence Thevenin theorem is verified. Thevenin theorem is verified. Again, we have to make a Thevenin equivalent circuit, which is, this is VTH and this is RTH, and here there is a load. The value, this RL is equal to suppose 10 ohm. The value of the load current in this resistance, suppose this is IL dash, must be same as in the previous circuit. Suppose the current in the circuit, in the given circuit, original circuit, when the RL is 10 ohm, the current in this resistance and current in the load resistance in the equivalent circuit must be same. Let's verify this on the LT spice. So make a Thevenin equivalent circuit. Let's first find out the value of the load resistance when this RL value is 10 ohm. So it is now 10. Now what is the current in this resistance? The Click on run and find out the current in this resistance, and the value of the load current is 254.71699 milliampere. Now make a Thevenin equivalent circuit of this, that is having the 6.75 VTH and the RTH is 6.5. To make a new circuit, let's new schematic and connect here draft component and the voltage, put it here, and one resistance which is Thevenin resistance, one load resistance, this is load resistance, and let's change the name of this resistance. RTH is 16.5 and voltage VTH is 6.75. Now connect these all resistance. So this is connected here and this is connected here and this one is connected here. So this is Thevenin equivalent circuit. Now let's change the name of this resistance. This is RTH and this is load resistance. Okay, and the value of this resistance is 10 ohm. Now find out the value of the current in this resistance. First draft and spice directory, and we have to write here and DC voice point, and that is .op, and put it here. Now run this. Okay, the circuit does not have a conduction path to ground. Please flag a node as the ground. So that means every circuit must be grounded. To ground it, let's net ground it and put it here. Now run this. Now you will see the current into this resistance. Then this is a Thevenin equivalent circuit, and this graph showing the load current into this Thevenin equivalent circuit, and the value of the load current is 254.7169, and in the previous circuit you can see the value of this is 254.7169. Here you can see the value of the load current in this resistance RTH is. Now in the Thevenin equivalent circuit, run this one and measure the current. Now here the value is exactly same. The current into this load resistance, that is IL, which is 254.7169 in the original circuit, and when we make the Thevenin equivalent circuit of this circuit, then that means the VTH is 6.75, RTH is 16.5 ohm, and the RL is 10 ohm. Then suppose the current in this resistance is IL dash, and which is around which is exactly same 254.7169. That means both current are same. So hence IL dash and IL are same. So hence Thevenin theorem is verified. Thank you.